I guess let's go to, oh, do I not have a library? What do we have in here? We have, oh yeah, we do have a library. Oh, I probably did B. Pubmod, this is process. Oh, you can't find it? Why can't you find it? You're in source, so I did that correctly. Less. Code ownership can't really apply on the decoding of a varant. Code ownership can't really apply on the decoding of a what? I don't know what you mean by code ownership. Like that the person's like, oh, this, like, I own this code type thing. I just more of, I want to make sure I give credit for who I'm taking this from. So that way, if anybody else wants to look at this, like, we can take a look at that. They can like go and take a look at this yourself. All right, so borrowing, because I'm borrowing because I'm not mutating it. Let's see, implemented using as a reference. All right. So a few different things here. We want to, we have our read type and size, and so we realize that we need to do this read variant byte first, and then okay, so then we get the, okay, so we do our function read variant byte, right? Yeah, read variant byte. I'm gonna put this over here so I can reference it. Oh, you just read the first entry using some of that code. Nice. Excellent. Well, then that lets us know that it's working. Whenever I move this to my other screen, it like completely changes where I am in the location of the window, which always has bothered me when I'm like moving things to like different resolution displays. It's like the operating system is still not good at like retaining where I'm zoomed, like where I'm scrolled, which really sucks. I don't know what to do about that. Okay, read varant byte. There we go. So read varant byte. So we're gonna take in our bytes. It's gonna be a bytes, and we're gonna return a result. Also, I really wish, this is more of just a negative on dev too. It has such a big advertisement thing on the right. I guess I can like full screen just that code, but that kind of sucks that I have to go back and forth with that. Okay, so I want to use anyhow result, and we're going to return from here a tuple of U8 and a Boolean. Okay, so first off, we get the first byte. So our first byte is going to be equal to bytes first. You can expect missing first. Okay, so we get the first byte out of here. And then we get the, okay, so the value is going to be this byte. So it's going to be our first byte. and that its ones line up. No, that any of its ones line up, I think. Is that how it works? And not. Now this varint continue flag. So we need to create. We're gonna have a const varint continue flag. It's gonna be U8 1. That's bit shifted left by varint encoding bits, just also U8 and equal to 7. So the right bits, so a byte is made up of 8 bits. And so we have, when looking at this from a binary point of view, we have 8 numbers next to each other. You'd stick with using the read trait. Can I do the read trait? Is that? Well, hold on. That none of this is using the read trait. This is all still not just using whatever this is. So do that. Then you bit shift left by varint encoding bits. So then we're going to do and not varint continue flag. And then we have more bytes. Okay, so that more bytes. This is going to be our first byte, and varint continue flag is not equal to 0. Okay. And then we return okay, and our value, and then more bytes. All right, so that's read the variant byte. Next we have the read size encoding. So we have our pub function read. Let's see. Amon Terom, hello. How are you doing today? What's the name of my theme? This theme. Is Adwaita Dark. If you pass the whole thing in each time, it won't know where the new position should be. So then the read thing is off of a file. So we need to save it as a file first to deal with that. Wrap the byte slice in an IO cursor. Ooh, I've never done that before. Okay, let's try that. Now we haven't gotten to anything where we were doing that with, right? Oh, except you're talking about read bytes here. We have like read bytes and then to get the stream, which gets me the first byte, but it's whatever has been seeked to wherever we are there. Okay, so then this would be not bytes, but something that implements read. Okay, that makes sense. Now does bytes implement that? What was it called? It's I think like seek. I don't think that bytes implements it, does it? So I would have to, yeah, we'd have to take the bytes, wrap it in an IO cursor, Now there's cursor. Cursor used with in-memory buffers, anything implementing as ref u8 to allow them to implement. Okay. Oh, yes, that's pretty simple. We may want to write bytes to a file on our, oh wait, this is just examples now. Okay, cool. So where would we do that? We would do that in clone. Okay, so we get the pack file information, and so at this point in time we now need our cursor. So we let mute. This is going to be our cursed commits. Yeah, so like cursed pack file. This is a terrible name. Cursor new, and then we want this to be our commit of 20 to the end. Oh, size for values of type U8 cannot be known. Okay, so I have to reference you. Bar move value commit. Okay, so we have to clone the commit. No. Okay, so I can't. Oh, do I have to turn it into, maybe I have to turn it into a vector. Don't pass it in a pack file above. Oh, yeah, I'm let's see, pack file. Are you taking the new bytes? Oh, wasn't it getting the slice from this? I was getting the slice from this. And I could really just do 0 through like 20. 21. Now, I think though the problem though is that I can't get commit. Okay, that does work. So now we have our cursor, which is over the U8. Okay, nice. I wonder if I can also give it... Yeah, I did give it away, didn't I? Okay, so we now have this cursor that implements read. So that's the reason why you're all implementing... So, okay, so I could implement this as a cursor like this. I could just say, I want you to be a cursor of a reference of U8, but I could also do the generic R, which also works. So if I just do like mute R, and this one is going to be, we want to read bytes. Oh, but we can't do that. So we have to do bytes. I want to seek get. I have to go find read bytes. Read bytes takes in the reader and then a const and usize. Okay, no, take in the stream. take in the stream. We want to get however many we're going for, which in this case, we're always going for 1, I think. Which is not defined here. That's fun. Okay, read exact. That's what we're looking for. So read exact. So read exact, and I want 1, I think. Oh, and I have a result already, right? Okay, so that gives me... Oh, but that doesn't give me this thing. Oh, read the exact number of bytes required to fill a buffer. Oh, I have to pass it in a buffer. Oh, okay. So yeah, I need that are bytes. Shoot. This is what do we want to call this? This is the commit bytes. This is the pack file. So pack file stream reader. I want to then get our bytes. There's really 1 byte. I'm taking the pack file reader, read exact byte. Oh, and that's it. Oh, And then I need to tell, why did I keep on doing that? I don't know why I'm doing that. So byte, it's gonna be equal to that one. It's a U8, one of them. And then we do pack file reader like that. Okay. That gives us our byte. So I don't need to do that anymore. So then we have byte and you. Byte and you. Okay, then you're happy. All right. So then we need to find where it was. Let's see. Kuvi Man, hello. How are you doing today? Thank you so much for the raid. How's your stream? And also Raiders, hello. How are you all? Hello, Nerdsal. You forgot how to code. I mean, I do that all the time. I mean, that sounds like a Monday too, right? A Monday problem. Davey is here. Hello. How are you doing today? What are you working on today? And hopefully you remember to code by the end of the stream. Oh, should do this the other way around. Like that. You're working on your game, but you did just a very tiny couple lines of code. There's been times that we've done that here too. Yeah, it's a thing, right? but hopefully things are working out well. Thank you again for the raid. For everybody who's come along, what we're working on here is a build Git from scratch. I guess like, no, it's not Git from scratch. It's build your own Git, and then we're using Rust for that. And we're as the guide for this is CodeCrafters. CodeCrafters is a tool. It's a subscription tool that you can use that basically does a bunch of scrimmages, like tests, like challenges, essentially. And then the Git one is what we're going after. And full disclosure, they did give me a free account and a code that can be used to purchase it, which then I get, helps fund the stream. So if you're interested in that, let me know, and we have a command to get that code, get that link. But yeah, we're currently working through this. We're at the very last stage of the entire project, which is, of course, the hardest one, which is cloning a repo from GitHub. So currently what we're trying to do is re-implement what we found here in this dev2 article, which is reading through what is called a pack file. And we did a request. So it's a 1-2 punch thing here. We did our initial request to GitHub, and we found this information, and we figure out, okay, this is the commit of the branch that we want to get. And so we take this and we pass it into ref discovery, and we get this back. And so we need to read through this thing here to figure out what it is we need to, well, all the commits. Like there's all the commits, all the files, all the other stuff is in here. And so that's what we're trying to get out. And that's what these things are going to help us do. At least we're hoping to. We have some, as Sitsu let us know, that this does work. So we're not going down a completely terrible path here. It's just time consuming, that kind of thing. So we just implemented read variant byte, but I don't really know if it's gonna work the way we want it to. I wonder if we can test this. Okay, so read 1 byte and then give us back the value and more bytes. So if we pass into here, so let's get rid of you. You're upset. Oh, okay. So here, let's can I find type R in the scope? Okay, so I need to, shouldn't it know that this is a generic? I think, okay, so we have to say that, is it something like that, where you have R and then your implement read? And then expected value found built-in type U8, that's, oh, right, I want you to be the type. So we have that, and then you're gonna be equal to an empty thing. Do I have to initialize you? I guess we do. And then we'll, oh, how do we fill you? Because if I don't set you to be something, you're gonna yell at me because you're mismatched types. How do you do this? And read bytes. Okay, yeah, you are initializing it to 0. So okay, so this is initializing it. Oh, interesting. Okay. So this is 0, and there's only one of them. And then we read exact to fill up this buffer, and then we return it. So Then we read exact to fill up this buffer, which is interesting that it's, okay, so it's zeros and size, okay. So we get our, then we get the byte out, which is read exact to the byte. Now this is a vector. Okay, so then I need our, technically this would be bytes, right? So then I want that byte. So then destructure that out. Then we're gonna do some bit shifting fun. Okay. They're gonna do some bit shifting fun and then return the value of this byte and then whether or not there are more bytes that we need to get. So we want to pass in the first part of this, which I think we've already done. So read variant byte from here. So we have our cursor, which is our cursed pack file. Because, you know, it's a cursor, right? A cursor over the pack file. And we're going to hand it that exact same thing right there. So let's do let variant byte equals read variant byte. We're going to pass it in the R, which in this case is the cursed pack file. You need to be a mutable reference. Okay, so cursed pack file. That question mark U. That gives us the U8 here in a Boolean. So if I just debug U, we're gonna have variant byte. So we want variant byte. Here we'll just give ownership to you. You're all good. All right, so if we now move over and run this. Okay, so our variant byte, we have 29 and true, there are more. Great. Okay. Now we have read size encoding. Okay, so in loop. Oh, so that's why we do read more bytes and then read variant byte with the next thing, because we are doing something. We get our value. Okay, so we convert the value to usize. Bit shift left the length, which is however many bits of data we've. Does the length ever increase? Oh, the length increases here. Okay. Oh, by the variant encoding bits, which is 7, because the one on the very left is the one that tells us that there's more. Okay, so then, all right. Next up. So we have pub function, read size, encoding. All right, so we know we're going to continue with the generic, so we're going to have a R, which implements read. We're going to take in our, now this is the same stream, but it's our pack file reader, really. We're going to return a result. And in this case, we want to return in, we're going to return the value here, which is the size encoding. And that is a, can you see this? Oh, it's kind of below Zilby, isn't it? Which is just going to be a usize. Okay. Okay, so what are we gonna do in here? So we set our value to 0, and we're going to or equals. Okay, so if they're is this if they're equal to 1 in any of the same positions? I don't remember my bit stuff. It's been forever since we did this with the ECS course, or the various. We implemented that like 3 times, and I've now forgotten everything about like the bit stuff. Okay, so that's gonna. Oh no, this is if you're not equal to 0 and you are equal to 0 and you're equal to 1, set it to 1. I think that's what it is, right? So we're updating value. So we're gonna start it with 0, 0, 0, 0, 8 zeros, essentially, like, you know, one byte of 0. So if we have our value, which need to be immutable, and then we have our length. So this is the number of bits of data read so far, which we're going to use to determine. Oh no, we're going to use this for shifting and making sure that we don't read the same bytes over and over and over again. So okay, so if you start into those things, now we're going to start our infinite loop, and we're going to read in a variant byte, which is going to give us this value, and then whether or not there are more bytes. So we have a byte value, and we have more bytes. Variant byte, and we're going to pass it in the pack file reader. Which reads in 1 byte, which reads in 1 byte from this pack file reader. Okay. We want to get, okay, so then our value is going to be or equals, okay, so then not or equals, it's this is the, if the ones don't line up, like set them. It's like set the ones, I think. We want the byte value, so we want to convert the byte value to be a U size. We need this to all happen together in one thing, and then bit shift it left by the length. So this is going to be our byte value as a U size, and then bit shift this length by the length. If there are not any more bytes, we're done and we return. Otherwise, we continue through. So if there are not more bytes, so if you're false, then we're going to return okay and the value. Otherwise, we're going to increment the length. So length plus equals to the variant encoding bits, which is the 7 of them, because the first bit is the are there more bits or not. Okay. That gets us to this U, and then we can return out of U. Oh, we don't return if you, it feels like it doesn't have everything here, right? Because the compiler won't let me do this. Will it? Oh, it will let me do that because this is an infinite loop. So yeah, either, interesting, either we're going to return this or we're going to stay in a loop forever. That sounds perfectly fine. Nothing can possibly go wrong here. Okay, so read size encoding. So let's come back to U. So we got our variant byte. But I don't really care about this anymore. So now we're going to do let our size encoding. And this is going to be our read size encoding. We're going to pass it in the cursed pec file, which is a mutable reference to it. Cursed pec file. And then we do that, and then we want to debug the size encoding is the size encoding. Okay. Spike Spaz, hello. How are you doing today? I don't care about you anymore. I don't know what you're talking about. I'm confused. Also, it's the first time chatting here. All right, let's try this again. So our size encoding is 1821. Now, I don't know if that's good or bad, but it certainly is a number and it's not a crash. So that's a good sign, right? So that's great. Let's find out. Let's go back down to where okay, read type and size. So we are going to, oh, nonsense take out of context from a statement of yours. Okay, got it. It shows you the mindset I'm in, that like you can tell me a joke based upon something I said and I just don't get it because I hyper focused on this a little bit too much. So sorry. Also, hello again. Anshul, hello. How are you doing today? CodeCrafters looks really amazing. I do like it a lot. The only negative to it is that it is really expensive. So it's one of those things where if you have a education budget, if you at a company you're working at, that would be, to me, that would be the best use of it. Okay, we can finally do, I believe. No, well, we can kind of start with this. We're missing keep bits. Okay, so read type and size. So we can start with this now. So pub function, read type and size. So we've taken our reader. So this is going to be our pec file reader. We're going to return a result with, this is going to be a tuple of a U8 and a size. Okay. We'll start with this. A U8 and a U size, right? Yeah. A U8 and a U size. And we're going to throw a to-do in here because we're going to run into trouble. We first find the size encoding. So now they're using the very helpful value name here. So let value equals, so read size encoding. We have to pass in the pec file reader. Then we grab U. So that's our U size there. And then we have our object type, which we want the keep bits. Now we have to go find what keep bits is, which is literally right above it if I had looked up. Perfect. So we have a pub function, keep bits. Now we're going to take in a value, read the lower bits of value. Okay, so that means the bottom 7. So we're ignoring the first one in there. Okay, so value is a U size, and then we want bits. which is a U8, which really this should be a bit, right? Like not a bits, but okay. We're gonna return a U size. And now we want, okay, so this is just a one-liner here. We're gonna take our value and we're going to and, so which wherever the ones line up. And then in here we have a 1 bit shifted left by the bits, then -1, which I can't remember what that does, but okay. We're just gonna blindly read it. Hope that it works the way we want it to. And we're gonna get our object type is now gonna be into keep the bits. So we want to keep the right. Okay, now we have to tell it which bits to keep, right? Because that's where this bits here is. Wherever the ones are is the ones we're keeping. So we have our the value that we're passing in, which is that size, okay. And then type byte size bits, which is a U8, you know, unsurprising. A var-int encoding bits minus type bits. Okay, and so we see like the type bits are the final 3, I think, of a byte. And then the var-int encoding bits, we already have in here, which is a 7. So, all right, so basically it's the last 4, but then there's some other weird stuff that might be going on with this. So, all right, let's add these in. So const, we have our type bits, which is U8. It's a 3. And this is going to be our var-int encoding bits minus the type bits. Was there anything else? No. Okay. So you're happy now. So then down here, we're going to say for the keep bits, our value that we got, which was the read size encoding, and then our type byte size bits. Or which is where the zeros match up. The and is where the ones match up, and the or is the pipe. It's not an or. Is it an or? Oh, I don't remember anymore. Then it's our value bit shift right by the var-int encoding bits. Bit shift left by the type byte size bits. And that's it for, that gives us our size. And then we're going to return an okay, object type, and then the size, which, that was just the object type. Oh, I did this wrong. Okay, hold on. So object type, value. Oh, wow, I did this very wrong. Let's do this again. Okay, so in keep bits, for object, this one here, we pass in our value bit shift right by type byte size. Okay, so our value bit shift right by type byte size bits, and then also our type bits. And then we make sure that that is recast as a lossy cast as a U8. And then now we're going to get the size. And now we're going to keep bits, and we're going to have our value just straight up as it is. And then also our type. Oh, interesting. Okay, so keep bits itself. So we do the type bytes like that. And then this entire thing, we then like that to then say keep the zeros, or set the zeros if the other one's 0. I can't. It's been too long. We have our value, bit shift right by variant encoding bits, bit shift left by type byte size bits, and that's it there. And now we can return, okay, object type size. Interesting. Oh, you need to be a tuple. Okay, there you go. Now you're happy. So now I can read type and size of the first object here. So read type and size. You take in just the data. Wait. Oh, it's the wrong one. Ooh. I don't want you. Okay. Read type and size. You take in the pack file reader, which is the cursed. Oh wait. You're fine there. Object type. You don't care about that. Okay, so now we should get object type. Which you're going to be a tuple of the U8 and the size. Okay. All right. No errors. Let's run this. Our object type is 1 and 237. Bean Pranjal or Pranhal, hello. How are you doing today? What a great time when you were thinking of building your own Git today. Nice, excellent. We're currently on the cloning part of Git, which is the hardest part. Is like just getting the information from GitHub, and then after that it should be relatively simple once we have the stuff. Okay, that looks right. Thank you, Isitsu. Okay, now type 1. Now, if I remember correctly, this was actually given to us somewhere in here was the different types. And I don't remember off the top of my head which documentation file that was. But I want to say that type 1 was a commit. It has been a week, though. And it's a Monday. I don't think I can have like a type. Let's see. How about a pack file? Maybe get upload pack. No. Oh, that's cool. You actually read a high-level guide from Git-let.js that implementation is in JS. Oh, nice. Pack format. Okay, that's where it is. Pack format. Go. Right, this is where it was. Okay, so yes, object types are git commit type 1. Excellent. Okay. Now, so if I want to turn this into an enum of what we're looking for, this is where now we have our types. So we have just a pub enum. Actually, we have this in the other file, don't we? Object type. Okay, so we want to grab all of you. Okay, so we have our object type. We have our commit unknown. Okay, so we do a new and then we hand it. Okay, so in this case, we're going to hand it the object type, which is a U8. So this is a U8. I want to match an object type. So if you're 1, you're going to get a self commit. Otherwise, for everything else, you're going to get an unknown. All right. Who wants to bet that I'm going to forget that I didn't implement the other ones and it's going to bite me in the butt later because I completely think that this is fully set up. Okay, so then object type. So instead of a U8 here, we're going to make this an object type. And so object type. Let's do the shadow object type here equal to object type new from object type. Okay, that should make you a lot happier. And then we'll just derive debug. Which means that if we rerun this now, private type, object type, oh, it's private? It is private.